Galaxies were once believed to be the entire universe. This was before the Andromeda Galaxy was discovered. Andromeda is a spiral galaxy similar to our own Milky Way. It is about 2.5 million light-years from Earth. For many years, it was the farthest known galaxy from our own. But did you know that it is not Andromeda that was first to be called a spiral galaxy? This is Mira. In this episode, we will wonder how galaxies are formed, why galaxies spin faster than expected, and what it can tell us of the future of the universe. The Whirlpool Galaxy, M51, was the first celestial object identified as being spiral. It was discovered in 1773 by Charles Messier. The Whirlpool Galaxy is located in the constellation Canes Venatici, and is about 31 million light-years from Earth. The galaxy gets its name from the spiral shape of its arms. The arms are actually areas of high density where new stars are being formed. The Whirlpool Galaxy is about 60,000 light-years across, which makes it about half the size of our Milky Way galaxy. The Whirlpool Galaxy is one of the brightest galaxies visible to amateur astronomers. It can be seen with binoculars or a small telescope. If you have a large telescope, you might be able to see the individual stars in the spiral arms. The Whirlpool Galaxy is thought to be interacting with a smaller galaxy called NGC 5195. The gravitational interaction between the two galaxies is thought to be responsible for the spiral shape of the Whirlpool Galaxy. The Whirlpool Galaxy is a beautiful example of a spiral galaxy. It is one of the most studied galaxies in the night sky, and has provided astronomers with a wealth of information about how galaxies evolve. Spiral galaxies are the most common type of galaxy in the universe. In the Hubble sequence of galaxy morphology, they are designated by the letter S, and can be further subdivided into subtypes according to their overall shape and the number of spiral arms. Spiral galaxies form a distinct class because of their spiral arm structure. The arms are regions of high density that winds outward from the center of the galaxy. They are thought to be density waves that are excited by the rotational motion of the galaxy. As the galaxy rotates, the spiral arms move through the disk and sweep up gas and dust. This compression of the gas and dust leads to the formation of new stars. The majority of spiral galaxies have one main spiral arm. This is often referred to as a grand design spiral galaxy. An example of a grand design spiral galaxy is the Andromeda Galaxy, which is the closest spiral galaxy to our own Milky Way galaxy. There are also spiral galaxies that have multiple spiral arms. These are referred to as flocculent spiral galaxies. An example of a flocculent spiral galaxy is the Triangulum Galaxy. Spiral galaxies are believed to form through a process of accretion and merging. Accretion is the gradual accumulation of mass by a system. In the case of spiral galaxies, this mass is in the form of gas and dust. This gas and dust is drawn into the gravitational potential well of the galaxy by its own gravity. As the gas and dust falls into the potential well, it forms a disk around the center of the galaxy. This disk is the location where new stars will form. The process of accretion and merging can continue indefinitely. As spiral galaxies accrete more mass, they can grow in size. This can lead to the formation of giant spiral galaxies. The largest spiral galaxy currently known is IC 1101. This galaxy is about 6 times the size of our Milky Way galaxy. It is so large that it would take over 100 Milky Way galaxies to fill its volume. There's something strange going on in spiral galaxies. They spin too fast. If you could take a ride on a spiral galaxy, you'd be whipped around like a centrifuge. The stars on the outside of the galaxy would be a blur. The problem is, there's not enough mass in a spiral galaxy to explain all that rotation. The stars we can see make up less than 10% of the mass of a galaxy. The rest is invisible. It's called dark matter. No one knows what dark matter is. It doesn't emit light, so we can't see it. It doesn't interact with anything else in the universe, so we can't study it directly. But we know it's there. Dark matter is the missing mass that explains the strange rotation of spiral galaxies. It's also the key to understanding the large-scale structure of the universe. In the early universe, dark matter clumped together to form the seeds of galaxies. The gravity of dark matter pulled normal matter towards it, forming the stars and gas we see today. Without dark matter, there would be no galaxies, no stars, and no us. So what is dark matter? We don't know. But it's one of the great mysteries of the universe, and solving it will help us understand the universe on a fundamental level. Spiral galaxies are some of the most beautiful and captivating objects in the night sky. In addition to their beauty, spiral galaxies can also tell us a lot about the future of the universe. One of the most important things that spiral galaxies can teach us is that the universe is constantly evolving. Over time, spiral galaxies will change in shape, size, and luminosity. This is because the galaxies are constantly interacting with each other, exchanging material, and experiencing star formation and supernova explosions. As spiral galaxies evolve, they will eventually become elliptical galaxies. This is thought to be the end stage of galaxy evolution, and it is believed that our own Milky Way galaxy will eventually become an elliptical galaxy. While the fate of spiral galaxies is interesting in its own right, it also has important implications for the future of the universe as a whole. Elliptical galaxies are thought to be the most common type of galaxy in the universe, and so it is believed that the universe will eventually be dominated by elliptical galaxies. This is significant because elliptical galaxies are thought to be much less hospitable to life than spiral galaxies. This is due to the fact that elliptical galaxies have very little star formation and are generally much older than spiral galaxies. Thus, the future of the universe may be a very different place than it is today. It is possible that life will be incredibly rare, or even non-existent. This is a very sobering thought, but it is one that we must consider as we try to understand the future of the universe. Keep wondering.